All right, today we're going to look at trigonometric functions, sine, cosine, and tangent. All right, there is a relationship between the angles of any right triangle and the sides. And the way we can find that, other than 45, 45, 90, and 30, 60, 90 degree right triangles, is to use trigonometry. The way we can remember the relationships of sine, cosine, and tangent and the angle to the sides is by an acronym called SOHCAHTOA. SOHCAHTOA. Okay? All right. O means the opposite side. H is the hypotenuse. A means adjacent side. Again, H is hypotenuse. And O means opposite, and A means adjacent. S is for sine, C is for cosine, and T is for tangent. So depending on what combination of sides, angles you have, you will invoke or use one of these three acronyms, which are sine, cosine, and tangent, to help you build the correct ratios. So first, let's look at the sine ratio. Okay. All right, the sine ratio is S-O-H. It means the sine of an angle is equal to the opposite side of that angle over the hypotenuse. All right. So the way we abbreviate it is sine of angle, and it's S-I-N, and you don't pronounce it sin, you pronounce it sine. Sine of an angle equals opposite over hypotenuse. All right, now, if we were to look at angle 2, okay, from this perspective, this would be our opposite side, and this would be our hypotenuse. If we look from angle 1's perspective, this would be our opposite side. So it all depends on what combination of angles and sides you have as to which one you're going to use, okay? And we're going to be looking at that. Cosine. Cosine of an angle. So it's pronounced cosine, but we spell it C-O-S, so you're not going to say cos, it's cosine. All right, so you say cosine of an angle equals the adjacent side over the hypotenuse. So we just abbreviate. Cosine of an angle equals adjacent over hypotenuse. Again, with respect to angle 2, this would be the adjacent side over the hypotenuse. With respect to angle 1, this would be the adjacent side. Again, when we look at the problems and see what number of combinations we have, we will be able to decide very quickly which of these trig functions we will use to help us find an angle or a missing side. And the last trig function we have is tangent. TOA, tangent of an angle. We spell it tan, but it is tangent, and we will say it as tangent, is equal to the opposite side over the adjacent side. So tangent of an angle equals opposite over adjacent, we abbreviate. Okay, it never involves the hypotenuse. So from angle 2's perspective, this would be the adjacent side, and this would be the opposite side. But with respect from angle 1, this would be adjacent and that would be opposite. So it's going to be dependent on what angle you have and where the sides are located. All right, so I can't emphasize that enough. So let's take a look at some problems and see how this works. So we want to find tangent ratios for angle E and angle F. So we're being told specifically tangent. So we're going to put ourselves at angle E, and I'm going to call it is angle E. So from this perspective right here, okay, from angle E's perspective, if I want to find the tangent of angle E, okay, it's got to be very specific, so you're going to write it this way. We have to look at what's the opposite, because remember, tangent is equal to opposite over adjacent, TOA. T-O-A, TOA. So opposite over adjacent, so you prep this. So the tangent of the angle equals, the opposite side to E is 6, but the adjacent side to E is not the hypotenuse. Remember, this is always the hypotenuse, no matter what. So it's going to be over 8. It's only the two legs that will change opposite or adjacent depending on what angle you're looking at, or what angle you're looking from. So this is our ratio. So tangent of angle E is equal to, in reduced form, this is going to be 3 over 4. All right, now, we also want to find the angle. The way we find the angle is we have to look at our calculators, okay? And we have to invoke what's called the trig functions, and they're right here, okay? They're sine, cosine, and tangent. And right above them, you can see there is a sine looks like to a -1, cosine looks like it's a -1, and tan to a -1. We call those inverse tan functions. So inverse sine, inverse cosine, inverse tangent. Don't ever say it's tangent or sine or cosine to the -1 power, because no one will listen to you. Okay? So if we want to find an angle, to find an angle measure, we have to invoke the inverse trig functions. All right, so in this case it's tangent, so we're going to invoke the inverse tangent. Okay, so what we're going to do is we're going to say angle E, the tangent of angle E, I'm going to write it up again, equals to 3/4. To solve for angle E, we're going to get this tangent over to the other side. So we're going to say angle E equals, and we're going to write it as the inverse tangent. So it looks like tangent to a -1 power, but we say it's the inverse tangent of 3/4. All right, now we're going to get our calculator, whether you're using a handheld or a Desmos. Phone calculators really won't work with this. Many of them do not have any of these scientific functions that we need. So what you're going to do is you're going to hit second tangent, and that's going to bring up the inverse tangent function. And then you're going to put in there a fraction button if you want, and then 3/4, and then close your parens, and it should look like that. All right, now you're going to hit enter, and you're going to get a number. Now you must be in degree mode. If you're not in degree mode, which is up here, then you have to go back and set your calculator to degree mode. All right, I'll show you that in a minute. But we are in degree mode, and we took the inverse tangent, and it's giving us the angle. So we round all angles to the nearest whole number, to the nearest degree, unless we're told otherwise. So this is 36.8, so we're going to round it to 37 degrees. So angle E is approximately 37 degrees. And you must put the degree symbol on here because you're looking for a degree, you're not looking for an side. Okay? Now, we also have to find the ratio for angle F. Okay, so the tangent ratio for angle F. All right, well, from angle F's perspective, okay, hypotenuse is always hypotenuse. It's opposite over adjacent. So opposite is 8, adjacent is 6. So it's going to be 8/6. So reducing that's going to come out to 4/3. So now that's our ratio. So we got that. Now if we want to find the angle measure next, we're going to take this tangent and bring it to the other side. And we're going to have angle F is equal to the inverse tangent of 4/3. All right, so let's clear this out. If you're not in degree mode, you go into mode and make sure the degree, which is up here, is blinking, okay, or highlighted. And if it's not highlighted, and then you can quit out. We want to invoke the inverse tangent, so second tangent, and we're going to put our fraction button, and we're going to put 4/3, and close your parentheses. Okay, so second tangent of 4/3. All right, and that's what you should have. Hit enter, and you're going to get about 53 degrees, because rounding it to the nearest degree, it's 53.1, so 53 degrees. So angle F is going to be 53 degrees. And let's think about it. If angle F is 53 degrees, and angle E was approximately 37 degrees, that makes sense, because this is 90, and the balance of this has to be 37 and 53, which makes up the other 90 degrees, the complementary angles, right? So whenever you want to find an angle, you're going to invoke the inverse function. All right, let's look at some others. All right, we'll do one more. We'll do it pretty quickly. All right, we want to find the tangent ratio for angle E, and then find the angle, and for angle F, and find the angle. So tangent of angle E equals, position yourself right here at angle E. Okay, tangent is, again, opposite over hypotenuse. Okay, and we're going to do tangent E is Opposite is 5. I'm sorry, tangent is adjacent. That's my error. Opposite over adjacent. So it's opposite 5, adjacent 5. So 5 over 5, which is 1. So that's our ratio. It's reduced, so it's 1, and you should reduce. Now we're going to get that tangent to the other side by doing angle E is equal to the inverse tangent of 1. Okay, now I think you guys can all figure out that this is a 45, 45, 90 right triangle, because if the two sides are equal, these two angles must be equal. But let's see if this works, okay? So do the inverse tangent, okay? So inverse tangent of 1, and it should look like that. Clear that off there. And now hit enter, and you get 45. So angle E is 45 degrees. All right, so that's that work. Now we still want to find the ratio for the tangent of angle F. Okay, you still want to do that. And again, angle F is going to be opposite over adjacent, which is 5 over 5 again, which is 1. So that's its ratio. And angle F is equal to the inverse tangent of 1, which we already know is 45 degrees. And there you go. That is how you work with the tangent ratios. And that is how you find a missing angle, by invoking the inverse function of tangent when tangent is involved. All right, now what if we want to find missing sides and we don't even have a picture of the triangle? That's fine, we can do that. Tangent of 46 degrees is a number, so this is just a number. So if you were to be in degree mode, go to tangent, and you're going to open up like that, just tangent, and then put in 46 degrees and close your angle. Okay, close your parens, all right, and hit enter. And you're going to get approximately 1.035530314, right? Don't round it to the nearest whole number, because remember, tangent of 1 is 45 degrees, but we're taking the tangent of 46 degrees, so it's a little more than 1. So we need that accuracy. All right, so this is just a number for us. We're not going to write this all down, and we're not going to calculate with all of this by writing it down. This is what we're going to do. We're going to treat tangent of 46 like a number. So tangent of 46 degrees equals x over 12. So we're just going to put tan of 46 over 1. We're going to cross multiply. So we're going to get 12 times the tangent of 46 degrees equals 1 times x, which is x. So how do we calculate that? Pretty easy. This is the way you wrote it, is how you'll put it in your calculator. 12, open up your parens, hit tangent, put in 46 degrees, close your parens twice, and hit enter. All right, and you're going to get about 12.42, and then we want this to the nearest tenth, so it'll approximately be 12.4. Another way you could do it is just say 12 times, and then hit tan, and then put in 46. All right, just like this. And then hit enter, and you're going to get the same answer. Okay, so that is how you find a missing side. So the side that you're missing is approximately 12.4. All right. Let's try another one real quick. Tan of 12 degrees equals 3 over x. Remember, tangent of 12 is just a number, long number, okay, ugly number, but it's a number, so we keep it in its form. We're going to cross multiply, okay? So we get x times the tangent of 12 degrees equals 3. We need to solve for x. Remember, tangent of 12 is just a number. So we're going to divide by the tangent of 12 degrees. We're not going to calculate it and then divide by like up to 4 decimals. We're going to calculate by the entire tangent of 12 degrees. Tangent of 12 divided by tangent of 12 is 1. Leaves us with x. And now your calculator. Okay? You can do a fraction button if you want, if it makes it easier. Put 3 in your numerator, arrow down, hit tangent, and then put 12 in, and then hit enter. And you will get approximately 14.11. All right, and we're finding a side, so we want to round it to the nearest tenth, so it's 14.1. All right, and whatever length that side might be. And since it's approximate, we should make approximate equal signs instead of equals. Okay, that is how you find a side length. All right, now let's find an angle. We want to find the angle to the nearest degree, and that's typical protocol. Angles are found to the nearest degree. So we don't know the angle. So it's just like we did before with tangent of angle E, we didn't know. So whenever we don't know the angle, we're going to invoke the inverse tangent, okay? So we're going to take that tangent to the other side. So x equals, and it's the inverse tangent of 3/5. That's all set up and written. You get your calculator out. You're going to hit second tangent. Okay, and if you want to get your fraction button, that's fine. Put 3/5. Arrow off and close your parens. All right, so it should look like this. And now hit enter. And you get 30.96. We want it to the nearest degree, so it would be 31. So x is approximately 31 degrees. And that's how you find a missing angle. All right, now what if you have a figure and you're trying to figure out how do we get this side? Now we have to decide, okay, this has to be a right triangle, by the way. We have to decide what angles we have with respect to the sides and what sides we have with respect to the angles. So we have an angle. So if we have this angle here, the side is opposite and adjacent to it. We don't have the hypotenuse. Hypotenuse is always here across from the 90-degree angle. So with respect to this angle 55, this side here, x, is opposite and this is adjacent. So we have to think of SOHCAHTOA. What are we using if it's opposite and adjacent sides that we have? Well, this is opposite hypotenuse, so sine is out. This is adjacent hypotenuse, cosine is out. So that leaves us with tangent, which is opposite and adjacent. So we want the tangent of the angle equals to opposite over adjacent. We have the angle. The tangent of 55 degrees equals the opposite side is x, the adjacent side is 5. That's what we want. Remember, this is a number, so we put it over 1. That way we can cross multiply without difficulty. So we have 5 times the tangent of 55, and it has to be written this way so that you don't make an error. You don't do tan of 55 times 5 because it's going to do something to the angle. We want 5 times, it's like a coefficient. That equals x. You get your calculator out, do it 5, tangent of 55. Okay, and you hit enter, and you're going to get approximately 7.1 because it's a side we want, so we want to round to the nearest tenth. Okay. All right, let's take a look at this one. 37 degrees. X and 3 are involved. From 37 degrees perspective, we have an opposite side and we have an adjacent side. Remember, this is always the hypotenuse. So we have to use tangent. So tangent of 37 degrees equals opposite as x over 3. So we're going to get 3 tangent of 37 degrees equals x. Get your calculators out. 3 tangent 37 is going to be approximately 2.26, so we're going to round it to 2.3, appropriately to the nearest tenth. And this one, we have an angle of 62 degrees. Remember, this is always the hypotenuse. With respect to 62, this is an opposite side, and this is an adjacent side. So we have to use tangent. Tangent of 62 degrees equals to 12 over x. We're going to put this over 1 because remember tangent of 62 is a number. Cross multiply, and we're going to get tangent 62 degrees times x. So we're going to say x 62 degrees times tan 62 degrees equals 12. Now tangent 62 degrees is just a number. So tangent of 62 gets divided. We're not going to calculate it, round it, and then divide because we're going to lose accuracy of our numbers. Tangent of 62 divided by tangent of 62 is 1, leaves us with x equals, and you get your calculator out and do 12 divided by tangent of 62. So you could do it that way, the old-fashioned division way, okay? Or you could just get your fraction button and put 12, and then put on the bottom, on the denominator, tangent of 62. You could do it this way, and then hit enter. And you're going to get x is approximately, because it's a side we're looking for, 6.38, so 6.4 rounded to the nearest tenth.